Check, check. Looks like mic's working. Hey guys. Hey everybody who's not watching. Hopefully people will come in and check out the stream. Who's not watching. Hopefully. Got some feedback there from another stream. Alright, let's keep an eye on the chats here. Cool deal. How's it going, everybody? Alright, so let's see. What I'm going to do is go to... my name's Ian. I am a software developer of about almost 20 years now. I'm going to be doing some C++ coding. I'll be using Claude Code just to kind of help me pile through some of the stuff out of laziness, if I'm perfectly honest. But I do need to learn a lot more. I'm still working on skills in C++. I have been doing some hand typing, but not a lot. And I do have a strong but not great understanding of C++ at this point. So today, basically, what I'm going to do is try to decipher some receipt text that I think I can show you. There's no credit card numbers or anything like that I can see. But yeah, let me get started here. See who's can check it out. Sorry, I'm moving text around here. Let's see. So I got... Okay, so here's the current challenge I got. Actually, let me bring up my other view here so you can see. Alright, so I've got this project I'm putting together. It's just basically it's going to be like a C++, how do I say this? Just C++ API written solely in C++. And basically it will have some different tools. One of the things I need to do is I need to parse receipts. And unfortunately, when you look at receipts, what you find out is, okay, so I'm using OCR, right? So I'm using an open source, it's Tesseract, to basically parse the text out of the image of the receipt. And I get all this kind of cruddy, not cruddy, it's actually pretty decent, if I'm perfectly honest. But this one actually I think parses out fine. Let me find the one I've been struggling with here. Let me switch over to this guy. This one was, I think it was number 4. I go down here to my receipts. And so what I got here is I've got some, like, you know, you might be familiar with this product, but it's water, right? So it's the description. This is how their receipt printer printed it out. I think that's actually in the original image. It might have had a period. It's kind of weird. Somebody probably typoed it maybe in the system. And then on the next line, you get the number 2, which is the quantity, how many waters I did, and then times the unit price of the product, and then you get a total for that line item. So these 2 lines are a total line item, and then you get this like poppy. I think it's like a soda thing, and it's like, you know, no quantity. It's just 1, and it's $2.49. So basically, man, inflation's really hitting hard, especially when you look at these prices. Long story short, when you look at what I did was I just put it onto one line of text. Whoa, got a bunch of tabs. I really need to start closing some apps when I stream, maybe. So if you look at the actual text broken down onto one line, you get, you know, this is what it looks like. And the challenge I'm having is I've put together this kind of custom grammar definitions that sort of try to detect. They try to detect the actual. It tries to parse all this information out of the receipt. So it tries to get like, oh, you got 2 items at $3.99 each, and this is the amount. And this just gives me a way to, when I parse it out, I can just verify in case the OCR screws up, changes digits around. It can still lazily try to interpret values even if they're really jumbled, and I can just do a check. I can say, well, I know that there's 2 items, the price got messed up, but if I look at my total, I can tell that the price got misinterpreted. So that's why I'm trying to get all these individual components so that I can have some post-processing validation of the actual receipt data and confirm that the information is correct. Now, the challenge I'm having is I've created some variants for, well, it's called fuel item, but there's actually different, there's actually one for these, let me take off word, and then if you look at, here's the challenge. So what I did was I thought I'd get fancy, and I basically asked Claude Code to modify my token parser. And I said, I want this special token that, well, it's kind of self-explanatory, scan line until. So it basically scans the line until either a new line is found or the end of the file, or it finds this match. It matches this rule. And if you go look at this rule, it's trying to find, let's see here, quantity at price. Okay, so it's trying to find this portion, and then the total item price, which is this portion. And that's fine. It actually works really well. The problem I have is that basically what ends up happening is it will, let me how do I describe this? So basically the challenge I have is that it, in the context of the full receipt, that kind of scan till, well, it doesn't, what it does is it scans and it finds this item. I think it actually bypasses the new line if I'm not mistaken. Let me go back to my grammar. Wait, that's not the grammar, that's the comparison. Let's see here. Where was I? Sorry guys, I got lost. Okay, scan line until. I'm gonna confirm with Claude Code. I'm gonna ask it to look at the code because I can't remember. Well, I could go look too, just to show you guys I actually do know a little bit about software development. Okay, so if you look here, if it's the current node is scan line until, it goes and calls step scan until, and then in here it's not the most efficient, but it is pretty fast, good enough for my use case right now. I'll refactor this another day. Anyways, long story short, what it does is it basically scans forever in this while true loop, which is kind of scary if I'm perfectly honest. I don't like while true loops. It basically says, well, if it's at the end of the cursor, that's the position in the text, or if it finds the next character is a new line. Okay, so it's going to stop. That's when it's going to fail, and then it's going to return because it hit the end and it didn't match the next target rule, which is our quantity and price. Once it hits that, it's just going to exit out. It's going to stop scanning. So the challenge I have is I want it to keep scanning till it matches the entire block. I don't really want, when you think in terms of parsers in general, they kind of don't see like a receipt structure like where's our receipt? They don't see this. Like, they don't look at it with like we do with our eyes. They just look at bytes and individual characters, and they're just going, looking for a sequence, finding the next sequence. Okay, there's a hidden new line here. It's going to kind of, generally parsers look at new lines as kind of irrelevant unless it's particular to your grammar or your kind of your code structure, which in this case we don't have code. We're not parsing code, we're parsing receipt data. So I want it to scan until, regardless of new line characters, I want it to scan until it finds this pattern. Then I want it to scan the next one till it finds a price, just a regular price pattern. The challenge that I've been running into today is it actually scans this line, which I actually want to parse out. I want to parse the subtotal as the subtotal. I want to identify the subtotal. However, it just scans through this, finds a price, and it ends up thinking it is an item. So it just keeps going through, and it finds tax, and it gets $0. It finds total, and it gets and then it just, the rest of my parsing is just basically just skips through all these, and it reports all these things out as items basically. And that's what I don't want it to do. So, and by the way, this is one of the downsides of AI is that while it did help me build like a large token parser in very little time, it's also caused a lot of headaches because of my misunderstanding of the code, because I didn't actually write it line by line, and I don't know always exactly the behavior. So it helps to go in and look at it, and just slowing down and looking at these things is actually more effective sometimes and more efficient, because in the long term, because it's like outsourcing your thought process. And if you outsource your thought process, you no longer get to control it. And the challenge I'm having is I've outsourced my thinking process. I didn't realize that what I was asking it to do was to, scan and just skip all this stuff. I didn't really realize it was going to just also, I assumed it was going to scan these, stop, scan the next one, stop, and then go, oh, okay, now I'm going to start trying the subtotal. Well, that's not what it does. So the challenge I have is I need this, because this will be run on a server and it'll be processing receipts. I need it to be efficient and fast. I need it to, basically I want it to scan and know when to stop. And so, so we need kind of like, I need a way in my grammar definition or an enhancement to the parser itself to basically be capable of knowing when to basically being capable of knowing when to stop. When have you matched lines, and now we know that we've moved on to the subtotal. Okay, so that's the challenge. Is I want it to, as soon as it locates a subtotal, I want it to back up, start executing the next grammar rule. So that's where I'm at right now, and that's kind of what I'm doing. So let me okay, let's go ahead and okay, so let's see here. I'm just checking chats and just cleaning them up. Sorry about that. Okay, no pressure at all. Nobody's watching me now, so that's cool. I just get to do my thing. So I think what I want to do, I don't want to like make my grammar super complex and say, hey, when you find subtotal, stop. But I also don't want it to, while it's processing the description, I don't want it to be looking for subtotal. And the reason why is because if I do that, every character has to go, okay, so it processes like the P here in Poppy. And then it says, is the next character, an S? Okay, no. It's a no. Okay, is the next character an S? It checks S, and it says no. Whoops, I screwed that up. And so it just keeps repeatedly, it keeps checking, right? And that might not seem like a big deal, but over time that makes the parser less efficient. It makes it slower. Because every character it checks, it's going to keep checking and looking for the bar in the S or the S itself. I might just have it skip and say, if you find subtotal equals currency, then I want you to realize you now need to exit out of the current rule and move on to processing the subtotal grammar. So this is the challenge I have, and I actually don't have the solution. And so that's why I decided to just go ahead and stream it, in case anybody's curious as to my thought process, how I solve it. And basically all I'm doing is I'm basically saying that once I find the next rules definition matching, maybe I should consider getting out of the current frame, getting out of the current rule that's being processed, and then move on to the next one. Another maybe a little more advanced, I could try to have it start looking to the next line for the next match. Like ahead of time. So I could do this. I could say, let's see. So I could remove the peak for, I don't want it to stop at new line anymore. So it's going to scan through my 2 lines, right? It's just going to go through and find the pattern. But what if I had it where it could be aware of the next, in the context of the current set of frames? How can I have it testing for the next frame? Maybe checking the next line. So since these are receipts and they are structured uniquely, relatively consistently with on new lines, that's just how the OCR is going to output them. I don't want to treat this exactly like code, because if you look at code, you have let me try to find something. Let's take a basic if statement. You look for an if, then you're like, okay, I know I need to expect an open paren and then some other stuff inside of that, and it's going to scan the stuff inside of that. Then I'll have a close paren, and then I expect this. Now if I just do like right, if I just do that, this is the ID, by the way, but if statement with constant condition. Okay, well let me just do let me just do this then, so it doesn't detect that. But anyways, oh wow, it looks like it's just going to optimize it away. Okay, just kidding. But yeah, it's going to, in general, some compilers will look for, it'll assume you need a bracket, an open close bracket, but it's going to start with the open bracket. It's going to look at the rest of the lines, and line 1, line 2, and I guess what all I'm trying to point out is that it doesn't care. Well, actually it does care. Well, no, it doesn't care. If I put these all in one line like this, that's valid syntax. So it doesn't care. It doesn't care about structure. It doesn't care about vertical lines. However, in a receipt, everything is going to be laid out like on separate lines like this. That's just how the nature of receipts. So perhaps in the context of a repeating quantifier, which a quantifier is going to be like, you know, I want to match this thing multiple times. Let's see, okay, so in this case I had, I think it was called gas lines. Hang on. It's kind of a funny name. Gas lines. Gas items. Go back. Okay, this is what it used to be. It used to be gas item. Okay, so what I could have it do, oops, not plus plus, it's just 1 plus. So the quantifier is going to be the plus. It's going to say repeat this rule. Keep trying this rule over and over again until it finally fails to match. What I could do is have some sort of look ahead. It could be while processing something like in the world of receipts, right? I could be saying that when I find my match, go ahead and just take a look at the next line. Go ahead and start trying the next rule on the next line. And if we have this gas totals starts to result in matches, then exit out of the current parent quantifier rule that's repeating multiple times. So, you know, basically if you go back to my rule and it's just scanning and scanning, I'm actually going to rename this to scan line. Sorry, you can't see that. I'm going to rename this to scan until. Yeah, 14 occurrences. Okay, because it's going to skip new line now, so it's just going to go until it finds this, and then a new line after it finds this this thing. So now what I want to do is I want to figure out a way to have it checking the next rule. And the problem with that is, how does it know what the next rule is? Is it one of these variants, one of these alternative branches that it could go down? Var B, var C, etc. D. Let's see. Or in the context of this gas item, how does it know that I want it to go and start looking at gas totals? That's the question. I think in this case, I could potentially, theoretically, safely default to the highest rule level as the place to look at the next rule. So it'd be in the token parser. I think it's called a frame. So if I look at if I look at this guy, this is being this is the guy being repeated. Okay, so let's see if we can do this. Let's see if we can do this without the help of Claude Code. If we go to our token parser, I'm just going to collapse everything so I can kind of navigate through this. If I go to scan until, okay. Yeah, so I think the trick here is I want it to go while not matching next parent frame. So let's just dig through this code together here, because I am looking some of this for the first time, if I'm perfectly honest. Okay, set position. This is the cursor. It's going to set the size t type to POS underscore private variable. So the current scan position for the current frame, which is going to be I assume it starts, okay, so it starts at the start position of the frame, and the frame comes from top, so the current top frame. All right, so let's do this because I am getting lost. Okay, so if I want to do, let's see, how do I standard out this? What's the syntax here? Well, that's great. Got all these qualifiers. Qualifiers on top of qualifiers. Take off my caps lock so I can type. Okay, let's see here. See out. Okay, so here's a sample. Okay, so see out, arrow, arrow. Okay, cool. Did it just collapse that for some reason? Okay. Let's just try this. Let's let AI kind of throw that in there. So scanning until rule. Ref name. Let's just see what the ref name is. Let's see if we can output that. And then let me check my grammar, make sure we're going to be testing the right stuff here. Okay, gas item, we got multi-line. Okay, so it's just going to try this one variant, which is the one I'm trying to match in receipt number 4. So I want to test against receipt 4, which I already have in my console here, and I'll do that in a second. But what I want to do is go ahead and build that. Okay, so let's build I have a little debug tool that I had AI write that it's just a command line tool that runs the parser with the training data to try and make corrections, and then it basically outputs the entire parse tree so I can see kind of what's going on. Okay, so let's make sure there's no errors. And I'm targeting OCR parse debug, so that's going to update my debugger binary. Okay, cool. All right, so I've already got this saved from earlier. So basically, I'll just break it down for educational purposes and for my own sake. So it's going to the build folder. The binary is called OCR parse debug, and then I'm passing it the rule gas station receipt, and that would be this rule here. That would be this this rule definition. Let's go back to that, and then so tree only. So I'm telling it to output the tree, and then basically I want to use the text from receipt number 4. Okay, boom. Okay, let's see what 1047 is. I think that's the total, but let's just double check. Yeah. So it got the subtotal or the total. Yeah, so it got, let's see here. So notice the parser shows it as a gas item. And it says, if you look at the text, it's debit. It's the last one. So it actually parsed this entire block, excuse me, as items. Okay. Let's see if we can see our debug output somewhere. I expect to see a break somewhere in here. Maybe not. Okay, it looks like something is... Oh, yeah. Look at all those. Holy smokes. Yeah, so it repeated... Okay, it repeated lots of times. Okay, so scanning until this rule. Okay. So now we know that that is the rule that's going to be... Let's see here. That will be the one inside. I think that'll be the one inside of the scan until. Okay, yeah. Okay, cool. Now, the current frame... Oh, the target, excuse me, the target frame, which is coming from... Which is appended as a... let's go do that. Let me see how I can... I don't want this to output 100 million times. Let me shorten up. Let me create a test version of the receipt and see if we can simplify for testing purposes. Let's see, I have a test file here. And I'm going to erase everything at the end. I'm just going to let it capture the subtotal only. And then let's see if that shortens that up a little bit. I wish I could, I don't know if there's a way, if this would work better if I just did, oops. I wonder if this, wait, why am I can't remember how to manually clear the screen. I haven't done it in probably a year. Oh, it's lowercase. I gotta stop putting on my caps. Okay. Let's go to our rule, okay, there's the test. Did it actually clear the buffer completely? It actually did. That's actually a lot better than just... I was using the hotkey to clear it. Okay, now let's do our test receipt. Our test contents. Okay. Okay, so it picked up the subtotal. Let's see how many... Oh, it's a lot shorter. That's much better. Still repeated a lot, but that probably just calling it for every single character. Not a big deal. I can work with that. Okay, so let's do this. Let's output. We know what the target is. Let's look at what the current frame is, which is probably going to be... Wait, why doesn't it... Let me try something here. Oh, do I have to do frame node to get the ref name? Let me double check something. Okay, so you want to get the current frame node. What was it, 587? Yeah. Okay, so if I go here and I do frame node and then the ref name for that node. Excuse my terrible casing. Alright, let's see here. Alright, let's go ahead and rebuild that. Okay, so it's item description. Let's go look at our grammar. Okay, honestly forgot what. Okay, so that is the current frame for the token contents located. It's going to be put in item description. And I only know this because I was previously I was working on it and updating it to capture. I wanted it to capture the. I wanted it to capture the contents under a named reference, or a named. How do I say this? A named node in the tree, in the parse tree for reference. So that way, if you wanted to get the description, you could access it by going to item description. All right, so we got that. So we know what the current frame node is named. Now here's the trick, the part that I'm not entirely sure on. And I might cheat. Now if I go to I want to go up to this parent, and then I want to find its next sequence, I think is what it would be considered. So I'm actually going to cheat because AI is going to be faster at this, believe it or not, as much as I hate it. Now what I want to do is say from the scan until method, how can I locate the parent nodes, the parent frame nodes next rule parents. Let's see, so frame nodes parents next rule sequence. I think the structure is just a tree, so I think I could go, let's just prove how smart I am, or not. Let's see, so if I go to the frame is the rule. Okay, so it's basically the frame represents a rule, I believe, if I'm not mistaken. You got a rule name, you've got some nodes, which I assume are, okay, you got grammar nodes, which are, let's see, rule. Okay, so you got different things. Different, a grammar node is basically the contents of the rule, as far as I can tell. Enclosing rule, that's okay, that's to propagate. For fuzzy lookup propagates to children. I'm not entirely sure how that works. Okay, you got some child. Okay, these are parse results. What I want to know is if frame has children. or parents. Let's do this. Let's go to grammar node. I don't see, this is a lot smaller, readable, and I don't see any parents. Oh, there's children. Okay. And you also have, okay, that's results. Okay, where are we at? We're at line 174. Let me look for a parent somewhere in here. You might have to pop. I don't know if that's correct. Okay, let's go back to, let's see what AI came up with, because I'm not able to figure it out here. It's terrible. What was the line I was on in the token parser? It was, okay, 587 or something. All right, let's see what AI says. It doesn't directly expose the parent sequence. You'd need to walk back through the state frames to find the parent sequence and check its next child. Ooh, that sounds really ugly. Let's see here. So I see there's a for loop iterating over frames, state frames. That makes no sense to me at all. Okay, however, there's a subtlety. Child IDX, child index in the parent frame, points to the child that's currently being processed, the scan until rule. So child index +1 would be the next sibling after scan until completes. Why, yes, I need it to stop when it finds the next grammar element, but it must quickly switching between scan until process, then switching to testing the next grammar each time it crosses, how do I put this, each time, actually let's not do cross boundaries or any of that. I think what I want it to do is I want it to testing the next grammar when upon each if the next grammars. Sometimes I find what's useful more than with AI is just getting your thoughts out sometimes actually helps you solve the problem without actually needing AI. And it made me realize that probably half the problems that people have is they don't just stop and just take notes. Just thinking through the problem, typing it out, like here's my problem and then here's my potential solution, and kind of forcing yourself, like pretend you're explaining it to somebody. If you struggle with like having inner dialogue, I personally don't struggle too much with that, but basically it is helpful to type the problem out, because you can kind of get get the thoughts out, and then you can see the flaws in your thoughts as you're typing them out. So if the next grammar matches, we should exit out of the scan until frame /rule. I'm going to stop it. When you come up with a solution, don't make the change. Just provide the changes to me so I can implement them piece by piece. This way, see, this is the thing, is like, if I just slow down and I just force myself to go through that process, I learn 10x. Like, people say, oh, you use AI, you become a 10x dev. I learn 10x by forcing myself to go through this process. And I'm also doing this too just for the sake of kind of trying to make a stream that's useful to people wanting to kind of either interested or just learning or whatever, just curious about it. And I enjoy it because it's actually a good for me too, for practice and learning. Just gonna check chats real quick here. I don't see anybody chatting. Okay, so it's got a solution here. So let's see. Okay, so let's add a helper function. Find next sibling, okay? Walk back through frames to find a sequence parent. Okay. We'll look at that more in detail here in a second. Replace step scan until with this version. Okay. I have no idea what's going on here. Okay, let's do this. Let's try, let's just first implement the helper function. Let's take this guy and then let's I hate one day I will probably have to refactor this entire thing. I hate loops inside of functions. It just feels dirty. And I understand it might be necessary in some cases, but I don't know that it's necessary in this case. I feel like you could probably... Actually, I know that there's... I'm very confident, let's just say that. I'm very confident that what you can do is actually, while it's processing the frames, it can make note of the tree as it's processing the frames and just create a pointer that basically gives you an instant way to jump to that not jump, well, yeah, in a way jump, but it gives you a way to instantly locate that parent sequence. So let me do this. Okay, find the next sibling node in the parent sequence. What are we doing here? Let's see. So find the next sibling node in the parent sequence. So we want to find the what are we doing here? So let's see. So we're iterating over frames, getting the okay. We're decrementing. So while, let's see here, so while I is greater than, so I is equal to the current frame size. So we want to start iterating down from that number, from the size of the current frames. For some reason we're doing I minus 2, which makes no sense to me at all. That's apparently, that would be the parent. Okay, we want to find a sequence. And if we locate a sequence, we want to get the parent frames child index plus 1. Okay. If it's less than the size, which means it's just within the array boundary or the vector boundary, then go ahead and return it. Okay, can the token parser track remember for more instantaneous access to its sibling? Let's see if that makes an improvement here. Compute and cache once in, yeah, see, this is ridiculous. I'm gonna have to do a major rewrite later. So what I can do, okay, let's just go with their implementation. I might have to rewrite this entire thing from scratch. All right, same logic here. So find next sibling, given the current state of the iterator. I don't know why we're going frames. Okay, if you go to stack frames, it has frames on it. So frame stack has frames, which is frames. It's a vector of frame. Okay, got it. So frames is, okay, so it's actually this is the actual array. This is just a frame stack, which has frames on it. So that's the initial starting point. Got it. Okay, so we get all the frames. Decrement, start from, start the size at the size of the frames, current, how many frames there are now. Go down one by one, always -2, so we jump ahead 2 index positions. going backwards. So we go -2, which means we're skipping every other, I guess. I assume this is because you're skipping, like, there must be an assumption of in between frames being like not knowing that they're not going to be node type sequence. That's my guess. Okay, so that's the helper. And then what I want to do is I want to call this from, this could be made static. I don't really want to make it static yet. Alright, so if we go down to our code for the scan until, now what I want to try to do, and by the way, let's see, this is line 601. What am I on here? Token parser. Okay, so the current class. So I should be able to just call it directly. So I should just be able to call, what was the name of that method? It was find next sibling. Okay, find next sibling. Okay, I did not. Oh, that's something else. Sorry. Yeah, I was gonna say I didn't expect it to expect that many params. Okay, so it's gonna expect the state, the current state. Okay, and it's going to return a grammar node pointer. Let's see here. Find how is it caching? Where is it? Let's see here. I can barely see the text. It's really dark, especially with these glasses on. They help, but they also make it really hard to see. Okay, scan start next match, find next sibling. Okay. And it's going to assign it to the next sibling on the current frame. And it's going to do it one time. Then from then on out, it can just look at this. If it has the next sibling, start matching. Okay, cool. So let's just do actually I can just do auto next sib. Okay, and then let's just output the next sibling, which is a grammar node. Does it have a rule ref? It's got a ref name. Let's do this. Let's do its let's go ahead and do its type. Let's do next sib. This is where I look like an idiot in C++. I don't know how to cast this to a string. I think what I want to do is, what kind of a cast would I want to do? Let's see. because the enum is probably some kind of an integer. Probably some kind of an unsigned integer, so it probably needs to be specially cast in order to make it something identifiable. Yes, they don't automatically convert to string. You have a few options. The manual way is a switch statement. Okay, screw it. Let me do... Yeah, I don't want to overload the... Okay, let's do this. So what does this say? Since you are inside of the token parser, the most direct way to adding external libraries is to write, instead of without adding external libraries, is to write a small helper function. In your step function, you are already switching on type. Yeah, let's just output the, let's not even try it. Let's not even output that. I figured that would be more of a pain than it was worth. Let's call this ref name. Next sib why is this complaining? Let's see. Oh, it's just a typo. Okay, I don't care about that. Or actually I do. Let's do this. That way I know I don't have an error. Okay. Go down here, build that. Wrong, whatchamacallit? Wrong terminal window. Okay, so let's go back to running the test. Okay, that is interesting. It didn't even match anything for one. And it didn't output anything at all. What else did I change? Wow, looks like a lot of stuff changed. Okay, there's the helper method I added. And then I added a output the ref name for that. Why is that? That doesn't make sense. What's what changed here? Let me check here. Why are these things what is changing? I don't see. Oh, I renamed a bunch. Okay, I renamed instances of scan until line or whatever. If we go here, let me just try see if this is actually this helper method might actually be breaking it. Okay, whoops. Let's try it again. Nothing. So now it's just not matching. Might be something I changed in the grammar. Whoops. Receipt grammar. Okay, let's go ahead and just remove. Oh, actually, I need that to stay there. Let's just let this execute one time. For now, let's comment this out. Let's uncomment that. Let's run it again. Boom, it broke. Okay. All right, so it's breaking when I have gas totals. Let's try doing this repeatedly, so it'll just keep matching. Okay, still not working. So what's wrong with gas totals? I don't get it. I actually don't know why it's oh, because it's required, maybe? Okay. It's required, and since it doesn't complete, it fails. Okay. I need to fix my posture. My lower back's starting to get a little irritated. I love getting old. All right. Well, it is matching the items, but it's the problem is, well, there's no problem. Let's go back to our, let's go ahead and let's uncomment this. I just want to see what the next sibling is, what it's finding from the helper method, given the current state. All right, let's see here. I think we rebuilt it. Let's go ahead and rerun that. Let's see here. Do we got our, nope. What's going on here? Should be outputting something. Oh, there it is. Okay, I just missed it. Yeah, okay, no ref name. Or ref name. All right, let's go to the grammar node. So there should be something. Okay, let's see. So this would be, I can still output, I could output the, I could just static cast to int. To get the type. Is there anything else that tells me anything about it? I can get the type and the ref name. The ref name is currently nothing. What is it called? A grammar node? Ref name. Okay, so let's go ahead and try the type. Okay, there we go. Alright, let's go ahead and rebuild that. Okay, what am I doing? Rebuilt. Let's try. All right, let's go ahead and clear that. Okay, so we got a node type 11. If we go look at the enum, if I can scroll 20 miles over to the right, can I break these onto separate lines? Will it let me do that? Does C++ allow that? Yeah, right on. All right, so let's go ahead and clean that up. Okay. Okay, so what was I doing? Let's go. That's right. I wanted to look at the enum. All right, so I think enums are they zero based? Wow. Okay. Alright, I got backups. Okay, never mind. It came back. Alright, so okay, so it's gonna be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's gonna be a new line. So it found a new line. Interesting. Okay, to debug, print the node type. That's expected. It's only populated for rule ref nodes. What did I say it was? It's a new line. Alright, this is not what I'm trying to achieve. I actually need to get the parent of this rule's parent. Next sequence. I want to ignore yeah, this is really complex. So what I want to do is I want to go up to the next qualifier that is multiples. Where's my arrows? There they are. Okay, so if we go gas items, okay, so this is one time. This is a singular match. It's going to match this variant, but I don't care about. So what I want is I need to locate the next parent above with a repeating qualifier like asterisk or plus. So in essence, that would be basically a node type of zero or more lazy Okay, so I think it's sticking by this this helper method. And then let's see here. So this is find quantifier next sibling. All right, I'm just going to replace this one because I don't need it anymore. All right, so what do we got here? We got okay, we get the frames. We're still decrementing. Okay, we're just going frame by frame now. And then we want to detect is the current frame of type repeating. Once we find the one that's repeating, we set size to the current index minus 1. So we go one frame back in essence. Oh, then an additional frame. I don't know what this is doing. J minus 1 after we've decremented. Let's see. Am I crazy? Let's see. The current index minus 1 is going to be equal to. Okay, so that's the initialized value. It's going to decrement on each iteration, and then it's going to it's going to keep minusing 1 from J. It's going to keep decrementing J, then doing J. Whoops. What the hell? Doing J minus 1 to get the parent. Why it does that, I don't know if why it's skipping Okay, so let's just go with that. So then it's basically going to say, is it of type? Okay, so we found the frame node that is repeating. Then we want to start. Let's see. We want to keep going back until we find the sequence for that. So it seems like we're going in reverse. So we're actually starting, like, so we're starting at the top level, and then we're saying go down one, and then see, this seems just so counterintuitive to me. So we're moving up the set of frames. From the end of it, we're moving toward the front of the frame, the array. Then we've got a parent type sequence. Okay, so the parent is going to be apparently closer to the front of the array, the vector, and it is trying to find the one that is a sequence, which does seem correct. So then it's going to add one to the current. Okay, so we find a parent that is a sequence, increment its child. Okay, got it. So what we're locating, what we're doing, I think, is we're trying to locate this guy right here. Its child index within this. So we're finding this is the parent. The current child index is going to be this. And then we're incrementing it by 1 to get to this next one. This, I guess, is considered a sequence. I thought it was a rule ref. Let me check here. Parent node type. I guess that's what this is looking for. So what I'm going to do is I'm actually going to standard out, C out this. I don't want the type. I want the, let's see here. I want the, oh, that's right. I got to do standard end L. Okay, what am I typing wrong? Oh, I'm missing a colon. Okay, so that'll print the ref name. And let's see here. Cool, you got next index. Okay, so we increase the child index by 1. I just want to see what the, oh, let me do this. Let me qualify this with something so I know what I'm looking at. Let's see, parent node ref name. I guess that may or may not help, but anyways, it's something. Okay, and then I don't need to make it static. Let's see here. So next IDX. As long as it's lesser, yeah, as long as it's within range, get that next rule and return it. Otherwise, all these returns are for null point. It's really, really great. Okay. I don't know where I'm trying to go in the code here. I think it's around here. There it is. So let's call find quantifier. Passing, I think it accepts the state, yeah. As a, and then it returns a grammar a grammar node still. So we can access that grammar node's ref name as well as its type, which is fine. Okay, let's try that and see what happens. Okay, it compiled, it ran. That's always a good sign. Parent node ref name is none. There is no ref name. The node type, though, is 2. That may be significant. All right, 0, 1, 2. So it's optional. The parent, the sibling, I don't think is optional. It should be one or more. Let me check what's Cloud Code saying here. The indexing is good. Here's a cleaner version with straightforward indexing. Okay, well, thanks for nothing. Well, I don't care if it uses it on accessing it. I just don't want to be wondering if I'm skipping frames and not finding the parent that I actually need to get in order to determine the next sibling. Okay, so this is the new code. So let's see. Frames, frame size, decrement, get the current frame. Okay, get the is it repeating? Okay, if it's repeating and I is greater than 0, do the same thing, decrement. What the hell was it doing before? It was just doing -1. Like, I don't know if that was random, if it just thought that was a good idea for no reason at all. Okay, so it's trying to find a node of type sequence, then get the child. Okay, let's see what that does. Let's print when we get a parent. I don't want to do that for every single time. When we get a parent of type sequence, we'll do parent. We'll do, yeah, let's do that. Let's get its ref name. It'll probably be blank though. Let's see what happens. We know it's a node type sequence because that's in the condition. Okay. All right, so parent node ref name, nothing. It's still number 2, which I think is what we were looking at earlier, 0, 1, 2, so it's optional. What is it finding? Oh, that actually is correct. That's actually correct. That is sounding correct. So if I go back, okay, so we're getting the correct node. I'm pretty confident of that. It can't be 100% sure because I can't tell the exact context. Okay. If I go back to Cloud Code here, it gave me this giant, crazy new step scan until method to implement. So if I replace this one with the new one, and it doesn't just screw up formatting like that. I don't know why it's not. Okay, let's see here. Okay, I just had to retype it. Okay, so if I do, oh, I remember it said you have to add scan until support. Yeah, but where am I adding these to? Where's the add field to frame struct? Oh, it's like parse internals, I think. Yeah, parser internals. Okay, let's see. If I do I say frame stack or frame struct? Where's the frame struct? Okay, so we already got a scan position. Okay, so next sibling, we can use that. Okay, I see. So it'll be on the frame itself. If I go back to the... Okay, so that works. Oh, I need to... Let's see, what line is this, by the way? 654. Okay, so that will call... find the quantifier next sibling. Let's see here. Alright, I'm going to switch back to my other glasses. I don't think I need these ones anymore. Just so I can rest my eyes. Alright, let's kind of go through this method. I wish I could make my screen bigger. It's really hard to work in such a small scope. I'm just trying to make it big enough so if you're trying to like watch on a smaller device, you can see it. Or even on maybe a screen that's further away. So if you go to... Alright, let's just go through this code here. So step scan until children. Okay, get the current frame node's first child. That is the target. So that's the next... I want to say that's the next item we want to match. So in the grammar, that would be like this guy. That would be, I believe, this guy. But I could be wrong, so bear with me here. Okay, so frame. Make sure the current frame is, if it is returning, stop it, set it to false. We're not returning anymore. If the last child succeeded, go ahead and create a capture and succeed. Scan position minus start position, that'll give you the length, and then the start position is obviously the start position. Mark it as success. Insert, so add it to the children. Okay, so we're going to add it as a match for, you know, so if it's returning, we want to go ahead and just, I guess we want to just go ahead and add that to the child results to later be processed, I guess. And then yeah, I don't know what this insert method's doing. Oh, that's just the standard vector method. Position. Okay, so we're adding it to the current frame's children, which is parsed results. So yeah, so it's actually adding it to the results, marking it as it succeeded, and then building the result from the current state. Okay, got it. Okay, so that's just some like boilerplate garbage. And then target failed. Check cached next sibling for early exit. If we look here, hold on. Just trying to check the chat, see if anybody's asked anything. State cursor. Set position. Okay, this is the key, I think. Check cached next sibling for early exit. Alright, this is where it gets kind of exciting to me anyway. So I think earlier, I think we cached... No, we haven't cached it yet. Where does this get... Okay, so down here we cached it, right? While we're scanning, we cached the next... If we're at the first position, we go ahead and cache the next sibling. And then on the next iterations of it, we basically say, if we have a next sibling, can start match, which is some kind of helper function. It does some crazy nonsense with a giant switch statement. Okay, so as long as we're not at the end of the file and the next character can match, yeah, given the current cursor and the next sibling, which is a grammar node, given the next grammar node, if go ahead and peek and see if it matches any of these, depending on the type. Go ahead and see if the next one is a match. And I think it was if I recall, it was node type 2, which was optional, which would be our total, that would be the total gas totals or whatever for the receipt. All right, go back. Sorry about that. Okay, cool. So if the next position can match our next rule, let's go ahead and mark the current one as succeeded. Yeah, this is this seems a little dangerous. Well, not dangerous, but I'm not sure this is exactly what I wanted to do, because I think it's going to peek the next character, find a match right away from the next sibling, and then say, oh, we're ready to go. Like, I found one character that matched out of the sequence, but I need it to do this only when I don't like this. This is dumb. Yeah, I need it to only do that when if we've I only want to go to the next one if I've successfully matched if this scan until has hit a match and the next sibling is starting to match, then exit out. The question is, how do you define starting matching? So if I go here and I look at my definitions, my rule definition file for receipt grammar, Yeah, so the next one's totally optional, so that's kind of weird. That's very weird. I don't think it's meant to be optional, although it could be. But basically, if this one is finished matching, I want to see if this one can match. If one of the sequences is able to complete inside of this, then we need to exit out of this. And in order for it to do that, it's going to have to do several iterations. After each match of this, it's going to have to go look at this, try to see if either of these match before giving up. Whoops. I don't know what in the heck is going on with my... Why is it going back to... What the hell is going on? I apologize for that. That's frustrating. Okay. So if I go, if it matches one of these like fuel item variants, right? Then it goes, okay, I matched one, try the next one, right? Okay, failed. Match the next one, try this one again. That's what I'm trying to do. The problem is that's a lot of iterations. It's a lot of checking and forward looking. It's a little bit costly for CPU cycles. And just in general, it's just a lot of executions. So I'm going to rehash this plan in my head, like just of how to approach this differently. And then what I think I'll do is I'll try to make, I promise I will try to create I'll try to stream. Once I think of something, I will try and stream what this kind of my solution is to this problem. But I need to think on this a little harder because I don't want to create all these extra cycles, but I also want to exit out of this once we know we're getting down to this point. And I'm sure there's a simple solution. I'm sure some of you out there, if you happen to catch this, you probably know already, but I don't know the answer right now. So I'm thinking what I want to do is get to, when I hit this, I mean, honestly, the simplest way would just be like, hey, if you see one of these characters, or but then what happens is some idiot, some person, some lovely wonderful person decides to put a bar separator in their description, right? And then it just basically just it just stops right here and it exits out early, right? It just fails. So I can't rely on that, but I can't rely on just this. I can't rely on just bar SU, I mean, Subaru. It's funny as that is. That's also an issue. So I can't just... I need to know that if I see this pattern, if I see subtotal equals, that's not a description. Or let me put it this way: if I see subtotal equals after, a bunch of items, which makes me think, I might want to just reverse the entire concept, the iterations, and just simply iterate over the receipt from the back forward. So start at the bottom of the receipt and then go work my way up, and then go through these things like this, because then I know that the moment I find these, And I thought about this before, and I should have went with that. That was my intuition, was to go this way before. Then once I get to subtotal, a strict match that requires something close, very either exactly equal to or similar, very similar to subtotal equals, then start looking for items. That requires I redo all of my grammar definitions, and that requires that I read my receipts in reverse. Cool. All right, well, I'll have to think of something. Thank you, everyone who's joined. If I haven't even seen anybody chat, so maybe nobody joined, but if you happen to catch this video, appreciate it. Give me a like, thumbs up, just to help me out, because I don't really have any viewers. And if you could just, yeah, if you want to share, if you comment, please. I love talking about this stuff, so feel free to hit me up on Twitter. I don't know if my handle's in there, but I am on Twitter as a Dangerous Bit Wrangler. And I'll show you my handle here. I don't think I got anything personal up here, but there's my handle, Dangerous Bit WRA, because it can't be that long. Yeah, so check it out. Say hi to me. Discord, you can see the down, see if I can point, oh yeah, down here at the bottom of the screen. And then yeah, on Twitch, got my Twitch down there. I'm on YouTube and Rumble and Kick. So cool. Thanks for joining. Peace out. Have a good evening.